In this section, we're going to talk about rational functions and how to simplify rational expressions. So first of all, a rational expression is an expression that can be written in the form p over q, where p and q are both polynomials. So maybe p is x squared plus 7x minus 4. That's a polynomial. Maybe q is 3x squared. That's a monomial, which is also a polynomial. And so as long as the denominator is not equal to 0, then this is a valid rational expression. Now, how do we find the domain of a rational expression or a rational function? So a rational function is undefined if the denominator is equal to 0. So we never want the denominator to equal 0. We want to find the values of x that would make that denominator 0, and then we say those values are not in the domain. So for the most part with rational functions, most of the set of all real numbers is going to be part of the domain. So you usually just have one or two values that are excluded. So we're going to set the denominator equal to 0 and solve for x, and any solutions that we get there are going to be values that are omitted from the domain of the function. So let's take a look at an example. So here we want to find the domain of each rational function. I'm going to start with a. My denominator is 8. If I set 8 equal to 0, well, there's no variable in the denominator. So this can't be the case. There's no values of x that would cause the denominator to equal 0. So my domain is the set of all real numbers. And I can just write that like this. I can also write the symbol for this set of all real numbers. So kind of a fancy R. And that's the answer to A. Now in B, I do have a variable in the denominator. So here I have x minus 7. I set that equal to 0. And I get x is equal to positive 7. So that value has to be omitted. So when I write my domain, I can write this in the form the set of all x such that x is not equal to 7, because we want to say what values are we allowed to use? Anything that's not 7. So that's my domain for part B. In part C, I have a polynomial in my denominator. I've got a variable. So we've got x squared minus 9 equals 0. And I'm going to factor that into x plus 3 times x minus 3 equals 0. So I get two solutions here. I get x is equal to negative 3 or x is equal to positive 3. So now when I write my domain, I'm going to write the set of all x such that x is not equal to either negative 3 or positive 3. So that's how I find the domain of those rational functions. Now let's talk about how to simplify a rational expression. If I want to simplify a rational expression, I'm going to factor the numerator and denominator where possible and divide out any common factors. So here we have a couple of examples. So first of all, I have x squared minus 2x minus 3 over x squared minus 1. And you can see that that's been factored, and we have a common factor. We have x plus 1 that appears twice. Remember, you have to cancel whole factors. You can't say, oh, x cancels with x. That's not legal. So let's not do that. And we're left here with x minus 3 in the numerator and x minus 1 in the denominator. And that's in simplified form. In the next example, I have 4 minus x times 4 plus x. So this is already factored. X minus 4 times x plus 8. So I don't have any factors that are exactly equal to each other, but I do have the 4 minus x and x minus 4. And those are negatives of each other. So 4 minus x is equal to the opposite of negative 4 plus x, which is x minus 4. So what I can do here is cancel these. They're not equal to each other, so they don't cancel to 1, but they do cancel to negative 1. So when I cancel those out, I'm going to put a negative in. So that's this negative here, and then we have the 4 plus x over x plus 8. So final thing is negative 4 plus x over x plus 8. So now let's do a couple of examples. Here I want to simplify each rational expression. So in A, I have 8x to the third all over 6x to the 5 minus 4x to the 4. The numerator is just a monomial, so I just bring that over. The denominator I can factor. I have a 2x to the 4 in common because 2 goes into both 6 and 4. And then the lowest power of x is x to the 4. So I can factor that out. That's in common to both terms. So I'm left with 3x minus 2. And now let's look at what we can cancel out, what we can divide out. So 2 goes into 8 4 times. Oh, let's see. That should be 8x to the 3. Okay. And then I have x to the 3 and x to the 4. So I can divide, and I subtract the exponents. 4 minus 3 is 1, so that leaves me with an x to the 1 power in the denominator. So in the numerator I have 4, and in the denominator I have x times 3x minus 2. And I'm going to leave it factored like this. You could multiply that back out if you wanted to. There's not really any advantage to doing that, because if we were going to do more with this, I'd probably want it in factored form. So I'm just going to leave it like that. Now let's take a look at part B. I have 5x squared minus 13x minus 6 all over 10 x squared plus 39x plus 14. And let's see how we can factor this. So I have a trinomial in the numerator, and I'm going to factor that into 5x and x. That's the only way to do that. And then the 6 could be 1 and 6 or 2 and 3. I'm going to use trial and error here. And let's see, I want the signs to be different because it's a minus 6, and I want it to turn out to minus 13x. So let's do a 3 here and a 2 here. 5x times 3 gives me 15, and I'm going to want that to be a negative 15. And then the 2 times the x gives me 2x. And so this way my inner and outer terms are going to combine to make negative 13x. right. And then in the denominator, again, trinomial. Now, when I look at this, I have 10x squared, and it's either 1x and 10x. But in that case, well, that might work. It might work. Because I have an x minus 3 factor in the numerator, I'm kind of expecting something to be able to cancel out. But more likely, I think, is for this to work out into 5x and 2x. So I'm going to try that first, and if it doesn't work, I'll do 10x and 1x. All right, so I've got 5x and 2x. 14 breaks up into 7 and 2. I don't want to put the 2's in a factor together. So let's put the 2 in with the 5 and 7 in with the 2x. I want a plus 39, and that's a plus 14, so the signs are the same. So I've got 5x plus 2 and 5x plus 2. Same factor, I can cancel. And my final answer is x minus 3 over 2x plus 7. So once you factor the first polynomial, and it can be either the numerator or the denominator, it doesn't matter. Look at what factors you have and see if it looks like one of those is going to be a factor for the other polynomial as well. Because you see that quite often, you're going to be able to cancel out. All right, more examples. Here we want to simplify each rational expression. In A, I have 1 minus 3x over 3x minus 1. Again, these are the same factor. They're just opposite in sign. So these just cancel out with each other and make a negative. So my final answer is just negative 1. That's a pretty quick one. In B, I'm going to factor my numerator. And you can put this in descending order, factor out a negative if you want to, or you can just go ahead and factor. Here I'm just going to go ahead and factor and do 7 and 4, which make 28. X squared is going to be x and x. And I want the signs to be opposite. I want to get a plus 3x in the middle, so I'm going to make that a plus x here so that x times 7 gives me 7x, and make this a minus, and that'll be a minus 4x, and that makes a plus 3x for the middle. In the denominator, I'm going to factor into x and x. 21 looks like 3 and 7. I'm going to put the 7 here and the 3 here, and I'm betting this is going to be an x minus 7, so that those are factors that can cancel, and that means that this should be a plus 3. So when I do cancel, they're not the same factor, so I have to put a negative in there, and this is going to turn out to be the opposite of 4 plus x over x plus 3. And you can either put the negative in the numerator or you can put it out to the side. They're both correct. You just want to make sure that you can see that negative off to the side. Don't just put it like right next to the fraction bar and then you can't tell, is there a negative there or is it just more fraction bar? So just make sure that it's really clear that that's part of your answer.